This is the giant package unit for the kitchen that we replaced the compressor on previously. So numerically, an alert went off that it's too warm. So we can see that thermostat has power. All right, so let's do this. Let's go over this way. All right, so red to common. So thermostat has power. Y1, which is cooling. First stage has power, so first stage should be cooling. Y2, second stage. So everything should be on. So this is first stage. You can see that contactor's not pulled in. Second stage is, and the blower fan is. So first stage should be running and it's not. So I'm gonna test, is there voltage at the coil, right? If there were 24 volts there, then this is just a bad contactor because it's not pulling in, but there's no voltage there, so it's being interrupted. The voltage for this runs through all the pressure switches. Let me reconnect this so we can show you that. All right, so power runs in this direction. So you can see this says circuit 1, so we're dealing with this. What I'm gonna do is I'm gonna measure, it should hold there. All right, so we have power going out to low pressure switch. Okay, so we have power going out, and do we have power coming back? Yes, we do. High pressure switch, power going out, power coming back. So there is 24 volts heading out to the pressure switch, but no voltage coming back. So, okay, so first we hooked up the gauges to know that I'm not legitimately off on high head pressure. So that sensor is off because it says there's too much pressure. Well, I'm only at 250. So I'm gonna leave this hooked up. I'm gonna come over here. I'm gonna pull these 2 wires that run to the high pressure sensor. I keep this just for this purpose, just for diagnostics. You can't leave it this way. But what I'm gonna do is, remember, we got 24 in, but not coming back. So I'm just gonna jump that sensor out by putting this on both sides. You'll see that contactor pulled in. And now the system's running. So we'll watch the pressure, make sure it's not gonna do anything stupid. So these fans are, pressure's getting really high because these fans are on a pressure switch and they have to get kicked in. Now they'll get going, they'll drop the pressure. So the reality is we have a bad pressure switch. The high pressure sensor is bad. You can see that it's torched in, so there's no way for us to change this without evacuating the system and retorching it in. So we have these. So what we're gonna end up doing is, here on the high side port, this will go on. We'll attach our new sensor to this, and then we'll still have our port. So we'll get that set up, and then we'll shoot again. Okay, so there's our ADA port, right? So that goes on. This is our new sensor, wired into the old wires. Still have our service port here. So once we made connection, that pulled in, and now we're running. And we just checked, we're running like 56-degree output air. It's dropped to 73 in there, so should pull down now. Keep going. Bad high pressure switch. That's pretty common, whether it's the high pressure or the low pressure. Those switches go bad. Just verify with the pressures that it's faulty failed and not legitimately failed. All right, it's 95 degrees. Let's get off this roof.